Hi guys. So for today, you are going to be going through a lesson with me on a video. And today's goal or learning targets are to be able to analyze strategy in solving quadratic equations and finding the key features of a quadratic in all forms. So we've learned everything that we need to learn about quadratics in factored form, vertex form, and standard form. Now we're going to kind of do a general overview. It's been a while since we've gone through all this stuff, so we just kind of want to put it all together and make sure that we have a good foundation of all of these skills. So today, in order to receive full credit in the gradebook for today's material, you will need to complete the following by the time we meet again next week. You will need to watch this Edpuzzle in full, making sure you take notes along the way, and answer all the questions as you go through so that I know that you were here, attentive, and you have got the material that we need. Then you will need to also make sure you complete the Desmos activity assigned midway through this lesson, as well as completing the 2 Khan Academy assignments at a 75% or higher that will be assigned at the end of the video. So watch the video, take notes. I will ask you to complete a Desmos activity. You'll need to make sure you get logged in and complete that. And then finishing up with 2 assignments, kind of getting some practice at what we go through in this video. So our first goal is to look at the features of quadratic equations in all forms and picking out what does each quadratic equation, or which does each quadratic equation form, tell us, and what is the most important feature that we can gather from it. So first thing, quick recap, which form is which. This is an important idea, is can we even determine what the forms that we've learned look like? So what I would like you to do in the response is match them up. Say A1, B2, C3. Obviously that's not the order, but match A with the number that it corresponds with, B with the number it corresponds with, and C with the number that it corresponds with. And then continue on with the video to make sure that you've got them all correct. All right, so if we did this correctly, we should have had factored form has our factors, has those sets of parentheses. So factored form goes with C. So this here is what factored form looks like. Something along the lines of 3x plus 2, x minus 4. So it's where we have those sets of parentheses. Vertex form, B goes with 2 here. This is what our vertex form looks like, where we have something squared, and then we're adding or subtracting a value behind it. And then lastly, we have standard form, which is the most recent form that we've been working with, and that would go up here. So standard form is what we've worked with probably the most, where we have ax squared plus bx plus c. So hopefully we can at least identify what form goes with what name. So factored form is our parentheses. Vertex form is when we have our parentheses squared. We add or subtract a value after that. And then standard form is ax squared plus bx plus c. At any point during this video, you are trying to write something down and I move on, go back, hit pause, and write down what you need to write down. So like I said, our goal for today is to be able to look at each form, recognize the form, and recognize what that form most easily tells us. So looking at the equation above, it's factored form. What feature can you identify the quickest? The zeros, the vertex, or the y-intercept? Go ahead and select your choice. Hopefully you selected A, the zeros. Factored form most easily allows us to figure out what the zeros or the x-intercepts are. So that is the one nice thing about factored form is it quickly allows us to find the zeros. So how do we find those zeros? Well, to find those zeros, we've done this many times. We need to set it equal to 0. So we would take our equation and we would set it equal to 0 because we are finding the zeros. And we would take these factors and set each of those equal to 0 and solve. Those would give us our x values, our zeros, also known as our x-intercepts. So in this instance, finding the zeros, we would get that x equals 3, and we would get that x equals -1. We're just using our inverse operations to solve. So factored form, our parentheses, readily tells us the zeros. To find those zeros, we need to set it equal to 0 and solve. So hopefully that's something that's coming back to us now. All right, we've got our next form. We've got y equals 3x squared minus 5x plus 9. So this is standard form, ax squared plus bx plus c. We want to know, looking at the equation above, looking at standard form, what feature can you identify the quickest? So what does standard form tell us? The zeros, the vertex, or the y-intercept? Go ahead and make your selection. Hopefully we selected y-intercept. Because remember, that is what standard form quickly tells us. And how do we find that y-intercept? Well, remember the y-intercept is always the c value. So in this instance, we would have a is 3, b is -5, and c is 9. So the y-intercept would be at 0, 9, where the y-intercept is always the c value. So factored form tells us the zeros. We set it equal and solve. Standard form tells us the y-intercept. So what does our last form tell us? So looking at this form, this is vertex form. So looking at the equation above, what feature can you identify the quickest from vertex form? The zeros, the vertex, or the y-intercept? Go ahead and make your selection. Hopefully you came up with vertex. Vertex form quickly tells us what the vertex of that quadratic equation is. And how do we get the vertex? Remember, vertex form is y equals x minus h squared plus k, where hk is our vertex. So when we're finding the vertex, inside the parentheses is our x value, outside is our y value. And remember, we want to think opposite, same. So we would get our vertex in this instance to be -2, -5, because we would think opposite of +2 is -2, same as -5 is -5. So that would be our vertex, which we can easily find from vertex form. All right, so let's do a recap. Features of quadratic equation strategy. Strategy meaning trying to figure out what each form quickly reveals to us. So I would highly suggest writing this down in your notes. And maybe you need to pause the video, write down, so that way you can focus on what I'm saying. Maybe you can write down as you're following along, but you always have that ability with the video to pause and write down what you need to write down and even replay it if you need to. So the big idea here is we have 3 different forms for a quadratic equation. We have factored form, vertex form, and standard form. So we can see here the general format of those, where factored form has our parentheses, vertex form is our parentheses squared, adding or subtracting a value after, and standard form is ax squared plus bx plus c. We just talked a little bit about what each of these forms quickly reveals to us. You were able to tell me those things. Factored form quickly is able to reveal the zeros, the x-intercepts. Vertex form quickly reveals the vertex. And standard form quickly reveals the y-intercept. Now, can you find all of these things from each of these forms? Absolutely. But these are what information is readily available. So looking at an example of each of these and how do we find this quick reveal from each of these forms? So factored form quickly tells us the zeros. And remember, to find those zeros, we need to set our equations equal to 0. And we only set the factors equal to solve. So we would get 3x minus 1 equals 0, and x plus 5 equals 0. And we would go through and we would solve, and that would quickly tell us our zeros or our x-intercepts, where it crosses the x-axis. And we do that by inverse operation. So here I would add 1, leaving me with 3x equals 1, and then dividing by 3. So that would give us one of our zeros is x equals 1/3. And the other one, we would do the opposite. We would subtract by 5, giving us x equals -5. So x equals 1/3 and -5. So by setting equal to 0, setting each factor equal to 0 and solving, we're able to find what x is, what our x-intercepts are. Now vertex form, given the name, quickly reveals the vertex. And that comes from what's in parentheses and outside parentheses. And we want to think opposite same. So our vertex here would be opposite same. So the opposite of -2 is +2, and the same as -3 is -3. So this reveals that our vertex is 2, -3, just by looking at the equation. And then lastly, we have standard form, and standard form quickly reveals our y-intercept. And our y-intercept is always our c value. So here would be c, meaning that our y-intercept would just be 0, -7. So that's the nice thing about each of these different forms, is that each one quickly reveals one of the key features of a quadratic equation. And we want to be able to quickly identify those features using these strategies. So what I would like you to do now is pause the video and go to student.desmos.com and type in the join code PEVKRX. Use your full name, your first and your last name, so make sure that you get credit for your work, and complete the activity. You'll do a little card sort, check your work, do a little card sort, check your work. Then you'll be able to exit out of that and come back here. So just in another tab, open up, get into the activity, do the activity, and then come back to finish our notes here. So now we've looked at each of the forms. We're hopefully pretty confident in identifying what form it is. What we want to also be able to do is find the most important things about each parabola, no matter what form it's in. The major key features of a quadratic are the zeros and the vertex, solving for x and finding its max or min. So we want to be able to do this in any form. Some are easier than others, but we want to be able to go through the process of finding these no matter what form you're given, whether you're given factored form or vertex form or standard form. So let's recap finding those things in each of the three forms. So what we've got going on here is finding features of a quadratic equation recap. So this is a lot of what we've already done, but just kind of putting it all together in one nice little organized note packet here. So what I'd like you to do is to make sure that you get this down in your notes. This is going to be super important, really nice to be able to go back and view how to solve and find the vertex in each of these forms, giving you a nice little example. Like I said, this is a video, so as you go through, if you're moving a little bit slower, writing down as I'm speaking, pause the video, write down it, and then be able to listen as I go through. You can always go back and rewatch it again if you need to after you're able to get down everything, but use that feature of pausing so that you're able to get everything down and understand how to find each of these things. But like I said, we've done this before. It's just a nice little recap, putting it all together. So factored form, finding the zeros. Well, we just said, well, this is what you can do super easy from factored form. So all we have to do here to solve is set it equal to 0 and set the factors equal to 0. So anytime we're trying to find the zeros in any of these forms, we always want to set equal to 0. So we're going to set this equal to 0. And to find those zeros, we're going to set each factor. So I would say, well, x minus 1 equals 0 and x plus 3 equals 0. And then I would solve for x, and those would be my solutions. So in this instance, I have minus 1, so I'm going to add 1 over, giving me x equals 1 as one of my zeros. And then in this one, I would do the opposite, subtract 3, and that would give me x equals negative 3. Boom, done. Zeros of factored form. Vertex, a little bit trickier. So the one thing we need to remember about a vertex is that it is both an x and a y coordinate. So we need to find both the x and the y. Now, the vertex is in the middle of the parabola, meaning both sides of the vertex are going to be symmetrical. So that means it's always going to be in the middle. So it's going to be in the middle of these two zeros. So to find the vertex, find the x value of the vertex, we want to find the middle or halfway between our two x values. So x1 would be 1, x2 would be negative 3. So if we add those up and divide in half, that's going to find where the x coordinate of our vertex is. So this would be negative 3 plus 1 is going to be negative 2. And negative 2 divided by 2 is negative 1. So our x value is negative 1. Now what do we notice? Well, we notice that the equation is y equals. Well, it's y equals when we have a specific x value. And we do have a specific x value here, right? We have x equals negative 1. So let's figure out what y is when x is negative 1. So we're just going to take that value and we're going to plug it in. Negative 1 minus 1 and negative 1 plus 3. So if we simplify using order of operations, we do parentheses first. Negative 1 minus negative 1 is negative 2. Negative 1 plus 3, 3 minus 1 is 2. And then we've got three things we're multiplying together. So we want to multiply them all together. 2 times negative 2 is negative 4. Negative 4 times 2 is negative 8. So that means y is negative 8. And we have our vertex, negative 1, negative 8. So that is how we find the zeros and the vertex in factored form. We also want to be able to do this in vertex form and standard form. So let's go ahead and take a look at that. Okay, so vertex form, find the zeros. Well, the equation has to be set equal to 0. How do we solve this? Well, remember, anytime we have something squared, we need to get rid of it. And in order to get rid of something that's squared, we have to take the square root. But we can't take the square root till we get all the way down to that square. So our goal is to isolate this squared piece. So we would have 3 times x minus 2 squared minus 27 equals 0. And we want to get this x minus 2 squared by itself. So we got to get rid of this minus 27 and this times 3. So we're solving. I would add over 27. And that would give me 3 times x minus 2 squared equals 27. Well, that squared piece still isn't by itself. I've got this times 3 still. So how do I get rid of multiply by 3? Divide by 3. And that gives me x minus 2 squared equals 9. Well, now I'm down to the squared piece. We've been doing inverses. Subtract, add, cancels. Multiply, divide, cancels. So we want to get rid of that square. We have to do the opposite. And the opposite is taking the square root. I take the square root of both sides, square root, square, cancel. I'm just left with x minus 2. I'm getting closer and closer to figuring out what x equals. Now, a big thing with solving by square roots is remembering that when I take the square root of a number, it's not just the positive value, but it's also the negative value. This is really positive 3 and negative 3 because 3 squared is 9, but negative 3 squared is also 9. So this is not done yet because I don't know what x is. It really sets up two equations. X minus 2 equals positive 3 and x minus 2 equals negative 3. And going through and solving. So I would add 2 and then add 2, which would give me x equals 5 and x equals negative 1. And both are valid solutions. Those would be my two x-intercepts. So I solve by taking the square root. Now this is vertex form, so we just talked about finding the vertex here. It should be pretty straightforward. Opposite, same. My vertex would be 2, negative 27. So that just comes right from the equation. And then hopefully standard form is a little bit more familiar to us because it's the most recent form that we've been working in, at least for finding the vertex. We should be pretty good at that. But the zeros, in standard form, there's really two ways. You can either factor, or you can find the quadratic equation, or you can use the quadratic equation to solve. So x squared plus 6x plus 8 is actually factorable. The ones that we're going to look at today are going to be factorable. So if you're feeling confident with factoring, I would highly suggest doing that because it's going to be much quicker. However, you can always use the quadratic formula, negative b plus or minus the square root of b squared minus 4ac all over 2a, but that would just take a bit longer. So we want to set it equal to 0, and I would suggest factoring to find the zeros. So I would factor this. So what multiplies to x squared? Well, x times x. What multiplies to 8? Well, 1 and 8 and 2 and 4. So how do I know which one to use? Well, it's got to add to 6. 1 and 8 is 9, 2 and 4 is 6. Okay, I want to use 2 and 4. Everything's positive. Now I need to remember, I'm not done. These are factors. So now it's in factored form. I essentially just converted it to factored form. Now I need to solve by taking each factor and setting equal to 0. So this would give me x equals negative 2 and x equals negative 4. Those would be my two x-intercepts, my two solutions here. And then to find my vertex, I need a coordinate. Hopefully we're feeling pretty good with this. Remember, to find the x value, it's negative b over 2a. So in this instance, b is 6. and a is 1. So that would give us -6 divided by 2, which is -3. So that would be the x coordinate of our vertex. How do I go ahead and find y? Well, my equation is y equals, so let's plug it in to figure out y. So I would get y equals -3 squared plus 6 times -3 plus 8. Now -3 squared, negative times a negative is a +9. 6 times -3 is -18 plus 8. So this would give me 9 minus 18 is -9. -9 plus 8 is -1. So my vertex would be at -3, -1. This is a recap of almost everything we've done so far this semester. Sorry, not this semester, this unit. Factored form, solving, finding the vertex. Vertex form, solving, finding the vertex. And standard form, solving and finding the vertex. I would highly suggest you have this written down in your notes, as we're going to start to look at a couple of examples here and have you work this out. So if you don't have this all written down, I'd suggest pausing, making sure we have these examples down before moving on. So given the examples, what I would like you to do is write down this example. Given factored form, y equals -2 times x minus 1 times x minus 5, I would like you to try and find the zeros, find the vertex, and then I would like you to type that answer in to the Edpuzzle and then continue on to check your work. So use the notes to help you out here. Write this down, try it out, type it in, and then continue to check your answer. All right, so taking a look at this here, we want to find the zeros. So what do we have to do? Well, none other than set our equation equal to 0. We would then take our factors and set those equal to 0 because of the zero product property. If either one of those is 0, the entire equation is 0. And then we would solve for x. So you should have gotten for the zeros that x equals 1 and that x equals 5. Those would be our two zeros here. Hopefully we got that. Then to find the vertex, we're looking for a coordinate. And to find the x coordinate, it is the axis of symmetry. It's right in the middle of any 2 points. So it's going to be directly in the middle of 1 and 5. So if we add up 1 and 5 and cut that in half, that's going to tell us the x coordinate. So we would get 6 divided by 2, which is 3. So x is 3. Well, how do we find y? Well, now that we know x, we can plug it into the equation. So we would get y equals -2 times 3 minus 1 times 3 minus 5, and we would simplify our parentheses and multiply. So we would get -2, 3 minus 1 is 2, 3 minus 5 is -2, -2 times 2 is -4, -4 times -2 is +8. So our vertex should be at 3, 8. If we did not get that, please make sure that we have that copied down in our notes. If you made any mistakes, make sure you fix those. Otherwise, hopefully we ended up with the correct answer. Now let's go ahead and take a look at the other forms. All right, so now given an equation in vertex form, y equals 2 times x minus 1 squared minus 32, I'd like you to go ahead and find the zeros, find the vertex. Go ahead and type in what you get for your answer, and then continue on with the video to go ahead and check your work. All right, so hopefully when we went to find the zeros, the first thing we did was we set our equation equal to 0. So we should have hopefully gotten 2x minus 1 squared minus 32 equal to 0. Now our next step is we need to get this squared piece by itself. So we need to move over the rest. So we'll start by adding over 32. And we're left with 2x minus 1 squared equals 32. Well, this still isn't by itself. We still have this 2, which is being multiplied. And the opposite of multiplication is division. So let's go ahead and divide. And now we finally have x minus 1 squared isolated. Well, we got to get rid of that square. To get rid of that square, we have to do the inverse, which is the square root. Got to do it to both sides. That's going to cancel the square root and the square, leaving us with x minus 1. And the square root of 16 is both positive and negative 4. It's a quadratic. It's squared. It's got 2x values. We should end up with 2 solutions. Now, this is not done yet. I do need to continue solving, and really I have 2 equations. X minus 1 equals 4, and x minus 1 equals negative 4. Continue solving. I would add 1 in both equations, and that would give me that x is equal to 5, and x is equal to negative 3. Hopefully that's what we got for our 2 solutions. If not, make sure we have that copied down. And then the vertex coming from vertex form comes straight from our equation. So it's going to come from here and here, and we're going to think opposite. Same. So that would give us a vertex of positive 1, negative 32. The opposite of negative 1 is positive 1. The same of negative 32 is negative 32. All right, moving on to a practice of our last form. And we're on to standard form. So given y equals x squared minus 8x plus 20, go ahead and find the zeros either by factoring or the quadratic formula, and then finishing up with finding the vertex. Have that down on your paper, work it out, type your answers in for me to see, and then continue on with the video to check your answers. All right, so for finding the zeros, my suggestion is to start with factoring. So I would factor x squared minus 8x plus 20. That is set equal to 0. And I'm going to factor. Could I do the quadratic formula with a being 1, b being negative 8, and c being 20? Absolutely. Work it all out. But factoring is going to be easier. So what multiplies to x squared? Well, x times x. What multiplies to 20? Well, 1 and 20, 2 and 10, or 4 and 5. Well, which ones add to 8? 21, 12, 9. Well, none of those. Well, we could subtract because there's a negative. Well, we would have 19, 8. Okay, 2 and 10. Well, which one's got to be positive? Which one's got to be negative? Well, I need a negative 8, so it's got to be negative 10. The bigger number has to be negative. Positive 2 minus 10 is negative 8. Now, those are my factors, not my solutions, not my zeros. My zeros come from when I set each factor equal to 0 and solve. So I would get x equals negative 2 and x equals 10. Those would be my x-intercepts, or my zeros. All right, finding the vertex. So finding the vertex is a coordinate. And to find x, remember it's negative b over 2a. So in this instance, a is 1 and b is negative 8. So we would have negative 8 over 2 times 1. two negatives make a positive 8. 2 times 1 is 2. 8 divided by 2 is 4. So our x value is 4. To find y, we plug it in. We know what x is, so we just substitute that in. So we would have 4 squared minus 8 times 4 plus 20. So exponent first would be 16, then multiplication, negative 32 plus 20. Left to right, 16 minus 32 is negative 16. Negative 16 plus 20 is 4. So my vertex is 4, 4. So hopefully after doing it all once, coming back and reviewing it now, it's all starting to click a little bit more. We're going to finish up here with a little bit of practice. So what I would like you to do to complete the day is complete the following assignments in Khan Academy at a 75% or better. You've got 2 assignments: features of quadratic functions, strategy, and features of quadratic functions. There are videos assigned with these, so feel free to watch those videos if you need a different perspective, you need some more examples, and then work to get these 2 assignments done. So make sure at this point, hopefully the Ed puzzle's done. Make sure we did that Desmos activity, and then complete these 2 assignments, and you are done for the day. If you have any questions, please feel free to send me an email. Otherwise, we will continue to practice these skills next week in class.